Good evening, everyone. It's fantastic to see all of you here again for Workshop 2, DataCrunch 2025. I hope you enjoyed our first session, where we explored the fundamentals of data science with Dr. Sandareka Vikramanayaka. As you all know, the DataCrunch competition is live on Kaggle. We are already seeing some fantastic progress on the leaderboard. We can see some amazing scores on the leaderboard at the moment. Don't stop now. Keep those submissions coming. For those of you competing in DataCrunch, mastering time series forecasting can be a game changer. Today's session will equip you with practical skills that could improve your leaderboard rankings. Before we dive into today's session, let's take a moment to introduce our esteemed knowledge partners, Xeptagon Private Limited. Xeptagon is a leading technology solutions provider specializing in climate finance, fintech, and R&D based software development to solve complex business problems. Their expertise in time series forecasting makes them the perfect partner for today's session. We are truly excited to have them on board and to learn from their wealth of experience. We are honored to welcome our expert speakers from Xeptagon. First, we have Mr. Palinda Athanayaka. He is the co-founder and CEO of Xeptagon. And next, we have Mr. Kavishka Ratnavira. He is the senior software engineer at Xeptagon. Their expertise and experience will provide us with valuable insights into building effective time series models. So, without further ado, please join me in welcoming Mr. Palinda Athanayaka and Mr. Kavishka Ratnaviram. Dear speakers, the screen is over to you.
Thank you, Tulasita. So I'll share my screen. Can you see the screen?
Yes, we can see the screen.
Right. So we can start, right?
Yes.
Right. So hello, everyone. Thank you for your time and thank you for coming for the session. And I'm Palinda Attanayak and I'm from Xeptagon, as Tulasita mentioned. And today I'm going to talk about some fundamental of the time series forecasting. So I'm not going into the theoretical side of it, but the practical aspect. And then I'm taking a basic example and walk you through a step-by-step guide on that. And at the end, my colleague Kavishka will walk you through a practical real-world example that help you to work on this projects that you come, like this competition that you are getting, right? So we can start the presentation, and if you have any questions, please let us know. So I'm not sure about the process, like you can raise the hand or then we can answer that question immediately or later in the Q&A session, right? So, first, what is time series data? I'm pretty sure everyone know what is time series data by now. So basically, time series data is time dependent data, right? So stock prices, sales data, sensor data, everything is time related. So it's a time series data. So there are a set of features in time series data, right? What are the characteristics of time series data? The first one is trend, right? Most of the time series data can have a trend. So it's not a must feature. There can be a trend. So if you can see the electricity production, because of the growing consumption, so there's an uptrend. So this has a uptrend characteristics. So this one is due to various reasons. The alcohol consumption is going down. So it has a downward trend, right? So this one doesn't have a specific up or down trend. So this one we can call it as a horizontal trend, right? So trend is one feature that time series data have. So other one is seasonal and cyclic. So this is something that very similar. that you need to identify which one is which. So seasonal is tick to the calendar. So seasonal, we know the time period of it. So it can be year, it can be month. So it's something like every April, everyone is buying clothes. So that event come every year. So that is seasonal. So we know every year, or maybe every end of month, you get Mahapal, something like that. Every year, so that event happens. So it's seasonal. For an example, in this graph, you can see this part is seasonal because it's almost like 1 year. Every year that event happens. It went up, came down. So that is a seasonal feature, seasonal characteristic, right? So then the cyclic means it's not depending on the time frame. It can be in 10 years, maybe 15 years, but it happens. So there's no guarantee that this will happen in this number of years or this number of months. So here you can see it went up, then went down. So there's a trend, there's an upward trend, downtrend, then uptrend, downtrend. So this gap is not fixed time gap. So this one has like 14 years. Here it's like 20 years. So cyclic means that, right? Hope it's clear for you. So then stationarity and autocorrelation. Stationary means, so there are a set of statistical properties in a time series data. In this type of time series data, those properties are constants, right? So autocorrelation means you compare a set of data on different time slots. Basically, we compare today data with yesterday data, right? So if it has a matching data, like data between today and yesterday, there will be high autocorrelation number. So if I explain this with an example, if you compare daily temperatures with today and yesterday, it's mostly similar. Like unless there's a major climate change, mostly it will be similar. April, we know in the evening it's going to rain. In the morning, it's very hot. Likewise, there's no major change. So there's a high autocorrelation between today and yesterday time temperatures. So on the other side, let's say daily returns of a stock, right? So you can't guarantee yesterday and today number of returns are equal. But overall, throughout the time, if you take the mean and variance based on the quality of the stock, that thing will be a constant. So we can say this has very low autocorrelation, but it is a stationary data set, right? So it's very important to understand these features because based on this understanding, you are going to do your forecasting, right? So there's some other characteristics like noise, is there any spike in the data, because of some reasons, then missing values, right? So you need to understand these features when you are exploring the dataset. So then what is time series analysis? Now you know what is data and its features, what are the characteristics. So then you want to do an analysis on top of that data. So for that, there are certain techniques that you can use. One is decomposing the data. So decomposing means, so you have to decompose the data into 4 parts. So one is level. So this is the only compulsory part in this the technique, and all these 3 are optional. It's based on the time series data. So level means if this is a straight series, what is the level of baseline value of that series? So then this trend factor, seasonality, and noise factor parts will come into the series. So you can see this explanation in this graph. So here, based on this data set, we can assume throughout this time period, it is going around 150, almost 150, right? And when you add this trend factor, trend part into that level, we get this graph. And this graph doesn't have seasonality and the noise factor. If there are a lot of spikes, then there are noise. And if it's going up, coming down, going up, coming down, so that means there's a seasonality, right? So right now in this example, in this graph, we have only two parts, right? So decomposing is one technique that you can use. So then now we know the data and then the characteristics, then how we can do the analysis. And then when you do the analysis, there are few additional things that you can do. So the other thing is feature engineering. So these are the things. So everyone have got access to the models, right? Like there are a lot of open source models, tools. So this feature engineering is something that you can do additionally. Like that this should come from your contribution. For an example, if the data is recorded per day, but you want to forecast per month, so then you can do some transformation to the month, like time-based features. You can add new features like based on the time. Or maybe time series data have a lot of fluctuations due to certain reasons. Like if you record the voltage, maybe there can be fluctuations, but you need to forecast, not like you need to ignore that the fluctuation. So then you can use add a moving window statistic feature. Likewise, you can add new features into the dataset that will help the model to get better results using these new features, right? So when you get a data set, you need to understand, so these are the issues. There are some issues. Model will deviate from proper results because of these features. So I need to add new features. So I need to transform this data set into this format. So then you will get a better result, right? So that is the feature engineering. So now we know about the data analysis, how we can add new features with feature engineering. So let's dive into time series forecasting, right? So where can we use time series forecasting? So there are a lot of places like inventory planning. So most of the garments now, there are a lot of shopping happening in Sri Lanka. Then like because of that, a lot of garments started this process during last year because they need to plan for the inventory. Like similar for manufacturing, like they need to plan their manufacturing. If they need extra laborers, they need to hire those laborers. They need to plan. So time series forecasting very important in those fields, like additionally financial forecasting, then supply chain management, energy load forecasting. So if we do proper energy load forecasting, there won't be any island-wide power cuts. So we need to forecast what is the energy consumption during this period and what happens if one of the power plant goes down. If we have proper backups, so then there won't be any grid instability, and we can, like, there won't be any power cut. So time series forecasting is widely used everywhere, even though we don't understand, right? Healthcare. So I don't think Sri Lanka is doing this, but during during the weekends, clinics are closed. So on Mondays, maybe we can plan more doctors and nurses during the clinic for the clinics. Likewise, then weather. So everywhere we are using time series forecasting. So something to think about. So think like, is astrology the oldest time series forecasting technique we have? So you can think on this, and like I'm not going to stick to this, but these are the current time series forecasting techniques that we have, right? So there are a lot of statistical methods that we used before, like few years back. So moving average, exponential smoothing, ARIMA, right? So then machine learning methods came into the context, and they also gave good results, but then deep learning. So recently there are new models called time series transformers. So those model transformers inspired by LLMs actually. So LLMs, what they do is they predict next text based on the given text. Likewise, these time series transformers, what they do is they predict the next number sequence based on the given number sequences. So this generative AI time series transformers also came into the context, and they are also giving good results for complex data sets, right? So then we can combine models and get better results as well. So based on your time series data, so you can decide which model that you need to use. And I'm not going into details about each of these models, because right now what you need to do is you have to do some like participate to the competition. So theory, like I'm going to explain how you can pick a model from this model, right? So so there are a lot of characteristics that you need to consider, and it's based on your requirement as well. So here you can see if it is stationary data and short term, you can use these models. So here what I'm showing is these are the possible models that you can use, but still maybe you can try different models as well, but mostly this is the best models that you can use. So when you pick models, maybe you can like start with these set of models, and then you can explore more models where what can I use, then you can do some other accuracy checks and pick the model, right? But like you can save time and resources by picking the right model based on this uh, uh, based on this table, right? So these models came recently, like Prophet, then Time FM, then TFT. So you can use this table as well. I added these tables for your reference. I will share this presentation at the end of the presentation, at the end of the session. So you can refer this table when you have a data set, and based on that, based on the features that you have, you can pick the right model based on this data set tables, right? So now we know there are a set of models that you can use, and now you want to understand what is the best model, right? For that, we need to forecast the accuracy. So how can we measure it? So there are two ways that we can measure. One is metrics, other one is model validations. So metrics means I think obviously you know these things, but I will like explain one like few. The MA mean absolute error means you take the average of the absolute difference between predicted and actual values. Then root mean squared error means you square root of the average square differences between predicted and actual values. So then percentage means you basically take the same absolute error but as a percentage relative to the actual values. So when you calculate this, if the actual value is 0, there can be issues. So you need to uh, pick the metrics based on that, right? So then RMSE and RMAE are relative MSE. That means you can use these metrics when you are benchmarking a model. Like you can compare with a benchmark models whether accuracy is good or bad. If it is less than 1, the new model is better than the benchmark model, right? Then cross-validity. So first I will go to the comparison of metrics. So when you pick a matrix, you need to consider the data set as well. So if your data set, like you need to get a interpretable metric that you want to do a business presentation or something. So then you can use mean absolute error, but here it treats all the errors equally. Like it won't penalize errors, actually like like it treats all the errors equally, right? And the scale dependent. Like if it is a count, the result also count. The metric value also count. If it is a rate, the metric value also rate, right? So this metric is suitable for dataset with large outliers, without large outliers. That means like, so there are no noises in the dataset. So you can pick this because it treat all the errors equally and give a basic interpretable metric, right? But let's say you are working on a medical data set that the prediction is very critical. It can like if there's error, that is a major issue. So in that case, you can use this root mean square error, right? Because it penalizes errors heavily than the MAE, right? So and that one also scale dependent. The remaining two are unitless because this one is percentage based. So if you are doing a business presentation, this is better because it doesn't have a unit. For an example, if you are presenting a generalized model, like this model supposed to predict the rate and the number, then this kind of metric is better, right? Then, but here cannot handle 0 and non-zero actual values, right? The next one is, as I explained before, we can use it to compare with the benchmark model, right? Right. So then the model validations. I assume everyone knows this and everyone use this. So this is basically cross-validation means you divide the data set into two data sets. One is test and the other one is train. And here, there's one thing that you need to consider when it's come to the time series data sets. That is, you need to shuffle the data, because if the data set has a seasonal pattern, so then you might pick the, like if you take the latest data set for the test data set, that data set can have a seasonal attribute, so then the results can be different than you expected, right? The walk forward validation means you divide the data set into few parts and like take first part and then predict the next one. Likewise, you go one by one. Like first take one stress set, then predict on the second test, then you take the both sets, then go to the third one. So there will be more iterations on the model, right? We can use this for testing as well. Then the tools, there are a set of tools that you can use, and there are a lot of like Azure providing Azure ML, then AWS Forecast, Google Vertex. There are more tools than this actually, right? So now we understood all the fundamentals of a time series data set. So attributes, how we can analyze it, what are the models that we can use, then how we check the accuracy, right? So I will walk you through a small basic data set, and I will give you a step by step how to get like forecast a time series data set. Okay. So this is the problem that we have, right? We are predicting daily sales for the next 30 days to help with inventory planning. And just additional information, shop is closed during Sundays, right? So hope you can see this data is recorded daily, right? So first thing is understand the business context. So here, what do you need to focus? Daily sales and focus horizon next month. So this is very important thing to know, because if it is short term, you might need to use a different model. If it is long term, you might need to different model, right? Then how frequently? So data is recorded daily, right? Are there external factors? Yes, holidays, right? So this is the business context that you need to consider. And so this screenshot shows based on this analysis, like if it is short term, long term, and the model results are like completely different. For an example, if you forecast for monthly, time GPT perform very well, but when it comes to hourly, the performance is very like comparatively low, right? So you need to understand the data set properly and the business context of it, right? So that's the first step that you need to do. Then data exploration. So you need to understand what kind of data in that data series. What is the maximum, latest, time span? Is there any missing values? Data type, is there any mismatch in data types, like some data in different data types, likewise, right? Then data processing. So if there are any missing values, maybe you need to like fill those missing values based on interpolation. You can use different interpolations. Here I'm added like a interpolation based on the linear method, but there are a lot of approaches that you can fill missing values. Maybe you can fill with zeros based on your requirement, right? Then resample. If the data is recorded hourly, but you need to forecast daily, so then maybe you need to resample. In our case, we don't need to resample it, right? Remove outliers. For an example, right now, we can't see any outliers in this data set, but let's say this shop, the in front of the shop, there's a construction going on. Because of that, less people come into the shop. So that is a outlier. So if there are some scenarios like that, you need to remove that kind of noises, outliers from the data set, right? So during the exploration, you need to identify that kind of attributes in the data set, right? Now we completed the data processing as well. Now exploratory analysis, right? Here what you can do is you can plot the data like similar in the second step, and then you can decompose the data, like identify the trend, seasonality, any noise, right? Then you can decide, okay, I have only this number of data, so I need to add some new features. You can add set of new features. So in our case, Sundays are closed. Maybe day of week is important in our scenario. So we can add day of week feature, right? So then rolling average. So we can give these features to the model instead of giving the raw value, right? And maybe drop existing fields. Then train, test, fit, right? Here what we do is, as I explained previously, like you can divide the data set, but randomize the data set before you divide it, and like the set of like one set for the training and one set for the testing. Then choose the forecasting model. Here in our data set, it is seasonal and it has missing data and it's short term. So based on that features, we can decide, okay, we can use Prophet Facebook, but there are a lot of models that we can use. So what you can do is you can pick set of models and you can like run the data set with through those models and identify which is the best one. But still maybe with some feature engineering, some low performing models can perform well, right? So you need to understand the features properly and the model properly, right? So then model training and tuning. So then this is where you need to like identify why this model is not performing well. Maybe I need to add new features. Maybe the training dataset is not properly created, likewise, right? Then forecast and evaluation. So here we check we use matrices and identify what is the error with this model, and then visualize the prediction and actuals and come to a conclusion what is the performance of this model, and then maybe you can combine models to get better results. You can give this output to another model and get the results, right? So that's the last step that you need to do. So do you have any questions, or maybe we can answer this question at the end of the session? Uh, so I will hand over the session to Kavishka. So he will walk you through a hands-on practical example uh, in details. Right? Kavishka, over to you. Thank you.
Thank you, Parinder. Am I audible to you?
Yes, Kavishka, I can hear you.
Yeah. I'll share the screen. Okay. I think you can see my screen, right?
Yes, can see.
Okay. Okay. Let's do some time series forecasting. So I took this notebook from another party actually, and I modified it. So I will set the both original one and this modified one later. So in a typical time series forecasting strategy, we have four main things. First one is data collecting, and the feature engineering, model building and training, and the final performance evaluation. So today I will mainly focus on this feature engineering part and the model building and training part. So today we are going to predict the air temperature of the next time step. So for that we will use this weather data set, and I'll take from this link. So this data set is consistent with 14 different features. The air temperature itself is a feature, because to predict the next time step temperature, we should have a previous temperature as well. And also there are some atmospheric pressure and humidity likewise features. And this data were collected every 10 minutes from 2009 to 16. So keep in mind, guys. So if you want to predict the temperature in 2025, so you don't you cannot use this old data. Try to get most recent data for your forecasting. Okay. So once we collect our data, we need to do a feature engineering part. So in here, we need to analyze our data,
and clean our data, and if we want, we can generate new features as well. So first, let's assume we want to predict next hour air temperature. So if we want to predict next hour air temperature, we want to have the hourly data. As I mentioned before, in this dataset, we have 10 minutes interval data. So how we can get hourly data from this 10 minutes data? The simple approach is we can select every hour start measurement. Like here, I took every 6 record starting from index 5. Like if we want to predict, now time is 6:40. If we want to predict 7 o'clock data, we could use 6, 5, 4, like hours data. And the other approach is you can take the average. So if you take 6 data records for an hour, like 10 minutes data, then you can get the average temperature, average humidity likewise. Then you can create hourly data as well. So in here, I do not take average, I just take every 6 record to our prediction. So once you get your data, the main thing you have to do is identify what are the features. So it is very important for the for further feature engineering part. So you have to get to know every feature and how they measure, because each feature has different numbers. So if we take this pressure, it's 996. It's a big number, and in this temperature, it's a small number. And if you see this number, you should have understanding about, is this a realistic value or is this a outlier? So to get that idea, you have to have better knowledge of your features. So learn about every feature in your data set, and then you can plot your data. Here, the first diagram is about the temperature. You can see this temperature is like a waveform for the whole time data set, and there is some outliers as well in here and here. And it's the pressure feature. There's no any waveform, but there are lots of outliers as well. So you should get these outliers and remove from your dataset before you do your training. Okay, and then as a next step, you should get your statistics of the data. This is very important because the different features are different in different matrices. So this pressure measured in the bar, and this temperature measured in the degree, and these values are very different. So keep in mind, you always put numbers into your model. So if you directly insert these numbers, maybe this number will get much priority than this second feature. But the actual thing is, this temperature is the most important feature for our prediction. So you have to get this statistics and analyze your whole data set before you do the model training and performance analysis. So here we can see there is a negative value for the wind velocity and the max wind velocity. So the velocity cannot be negative value, but there is a negative value. Yes, surely this is a outlier. So we should remove them to know whether there are outliers or whether there are some wrong values in the data set. So you have to have proper understanding about the features and their statistics. So once we identify some issues in our data or outliers, then we can go to our data cleansing part. So first thing first, we should remove these negative values from the wind velocity, because velocity cannot be a negative value. So we can replace with 0. And also there are two features called wind direction and wind velocity. So wind direction means the direction which the wind go, and the velocity is the speed. So, and this wind direction is measured from degrees. So degrees range from 0 to 360. If we input this value to our model, it will think this is a complete opposite value. But the truth is the 0 and the 360 are both same. So we cannot insert this angle to our model. So we need to do some fit engineering to remove these degrees and make more sense of our data. Okay, here one thing we can do is we can create a wind vector using the wind velocity and the wind degree. So for that, where we can use this cosine sign. So I think you guys know about these vector things and how this cosine function works. So I will not go through the mathematical part. So here you can generate new two features, Wx and Wy for wind, and max Wx and max Wy for max wind. So these features both collaboratively give you the velocity and the direction. So, okay. And another very important factor in this time series forecasting, the timestamp. Most of our dataset will consist with timestamp, but the date will be in a string format. So we cannot insert a string to our model. So we have to convert into int or like number. So if we convert our date time into a number, yes, now we can insert into our database, insert into our model. But the problem is that time is a constantly increment value. Like it will be a straight line from the beginning to end with a constant rate. But if we try to predict the temperature, like temperature is not a constant value. It's like a periodic value. So the temperature will be depend on the time of the day and the day of the year. So if we insert this timestamp value to our model, it will not capture the temperature periodicity. So we have to convert this timestamp into some waveform. So we are doing this because the temperature behaves as a cycle. It has a daily and yearly periodicity. For that, we again use sine and cos functions, and we can generate new two features: daily sine, daily cos, daily sine, yearly sine, and yearly cos. So we need both these sine and cos because sine or cos alone cannot interpret all the timestamps uniquely. So we need to have these both features. Okay, and the temperature itself has some periodicity in daily and yearly. To extract that, we could use Fourier transform. So this Fourier transform is also a very common approach in the time series forecasting. So here this Fourier transform is used for identify if there are any periodicity of our prediction value. Like here you can see our temperature value has yearly and daily periodicity, and other month or other hours, so it does not show any periodicity. So using this, you can understand how to generate your cyclic features like this day sign and yearly sign. And also, this Fourier transform can be used to identify a multi-frequency pattern. So this multi-frequency pattern means, so this is a sample of the Bitcoin price. So this the pink one is the real price. So you can see there is high volatile and very noisy. So if we can write our BTC price in a Fourier series, then we can identify different frequency patterns in the data. Let's say if we decompose our Bitcoin price into this Fourier series and take first three as a combined value, then it will give us this the blue line. So this blue line will show us the long-term pattern of the Bitcoin price. And if we accumulate another 6 component of the Fourier series, it will give more variable pattern. So it can be used for identify the more short-term patterns. So if we take 100 components of the Fourier series, it will give a nearly the real pattern, and it can be used for identify like 5-minute pattern, 10-minute pattern likewise. So this Fourier series also very helpful for identify time series pattern in the data. And I have listed some other techniques we can use for the time series analyzing. First one is generate features from logarithmic change and percentage change. This is very important because if you think a stock price, like your stock price varies from, let's take two scenarios. Stock price varies from 1 to 2 and 24 to 25. So in both scenarios, the price increment by $1 or 1 rupee. But if you think in a good manner, you can understand if price goes to 1 to 2, the price is doubled actually. It's twice than the previous price. But if price goes to 24 to 25, it's a very little increment, right? So if you want to capture those things, you can have this logarithmic change feature and the percentage change feature. So these features are calculated by like the percentage change. You can take the previous value and measure what percentage change in this time state, likewise. And also we can use variation autoencoders for the new feature generation. So these features are not compulsory. You actually you should not use these all features, all steps. So when we do in our analyzing, we have to decide what are the steps we are going to do. And PCA, principal component analysis. So here this one is very useful when we have lots of features. Let's say in this example, there are 51 features in our dataset. But let's say we have two features that are very much related, like wind and humidity. Let's say when wind go up, the humidity also go up. So if there is a very much close relationship between two features, actually we don't need these two features, because these two features only give us one information. So we could use this PCA to avoid that kind of features and take independent features which gives the same information as this large feature set. In here, we could use 21 features. So they will give the same variation, the same information which were given by these 51 features. So this can be used for our feature reduction task, and we can use XGBoost. So this XGBoost is for feature. We can use for feature selection. So let's say you have a very independent, very valuable feature, but does not relate to temperature. So there's no point in add our data set that feature because we cannot predict the temperature using that feature. So we should remove that. To identify those kind of features, we can use XGBoost, and also we can use heat map for identify correlation things. So these are the steps we can do in our feature engineering part. So, and once we done with our feature engineering, we can take our data and split. So if we have a large data set, like 1,000 or 100,000 of data, we can go like these numbers, like 70% for training, 20% for validation, and 10% for testing. So if we have a very less number of features, less number of data rows, the numbers can be different. So here we will use this figure for our training, validation, and test. And to before we inject our data to a model, we should normalize our data because the data are measured in different matrices. They have different ranges. So we have to get all ranges into one range. For that, we could normalize. Here, we just take the mean and standard deviation. Then we take train df as our original value, and we reduce train mean, and then divided by the standard deviation. From this, we could normalize our data, and then we can take all our features into a single time range, like single value range, like -10 to +10. So here we have all our features in the same range. So here we have 19 features. So these are the newly added features, WX, WY, and so on and so forth. So once we have this data, then we should do a concept called a data windowing in the time series analysis. So this data windowing means, I'll explain with some example. So I will not go through this codes because it will take a lot of time. So what this Windows generator do is, let's say we have input with 24. This 24 mean to predict one step ahead of the future, we will use 24 previous time steps. Likewise, so we could use different time window for our prediction. Like if we can take 6 hours of data to predict the next hour data, over 10 hours or 20 hours. The number we could not get this arbitrary. We have to have some model training and evaluation, then identify what is the best value for this input width. And label width means how many time step we are going to predict. Here we will predict only one time step ahead, so label width will be 1, and shift is 24 means we will skip 24 hours, and we use today data and predict the next day temperature. So and data split is a very critical feature in the time series forecast because when we input our data to a model, we have to use this windowing concept. Here I will explain with the example. Okay. Here, before we input our data to a model, we have to have this data window done. So what it does is, it will output this three-dimensional data. So what is this dimension? So this 19 means our features. We have 19 number of features, and the 6 is how many time steps we are going to predict the next time step. So here we use 6 hours of data. Each hour has 19 features, and we will predict one time step ahead and only one value. Here, using 6 hours data, we predict that next time step temperature. And this 32 minutes batch size, I think you already familiar with these things. So you have to have this clear idea about this three-dimensional data while you're training the model, because there can be lots of issues or confusion with working with this three-dimensional data. So once you have this data, we can do the model implementation and training. So let's go to some simple neural network model first. Say we input 3 time step as the input values, and we want to predict the next time step temperature. So for that, first we should generate our data window. Here you can see we have 3 times step data like 0, 1, and 2, and this is the label data. So this is the training data we are going to use, and we will use 3 times step data. So these are the 3 times steps. So this is first data set with 3 times steps like 0, 1, 2, and this is the next data set 0, 1, 2 with variation, and this another data set with another variation. So we could have 1,000 of this kind of batches for our training. So let's implement the model. Okay, and this will be a simple neural network with dense layers. So first, in our model, we have to have this flattened layer. This flattened layer is we required because we cannot insert three-dimensional data into our simple neural networks. To input the data to our model, we have to convert into this two-dimensional data. Let's say we use 3 time steps, and with 19 features, we have to take this 3 and 19 data set and make it into a one list, like 57 features. That's how we input data to our model. And then others are normal layers, like dense layers with a ReLU activation. And the final dense layer which have 1 unit. Because we need only one prediction. So once we build this model, now we can input our data. Like our input shape has 32 batches and 3 time steps and 90 features, and we will output 32 batches and 1 time step ahead the temperature only. So once we build our data and the model, we can do our training. Here I use a function for the training. So this is depend on how you implement this. So you don't have to have this function. So you can just implement this as a normal script also. So in this compile and fit function, what does it do it? just take the data and take the model and do the model fitting and training. So this there is a list of criteria. So this is useful for avoid overfitting the data. And this model compile, we use mean squared error. So this will be the loss function of our model, and we will use the Adam optimizer. And for the validation data set, we will use mean absolute error. So after we train our data, we could validate our model with our validation data set, the training data set as well. So this is a validation data set preview. Here you can see 3 time steps, given 3 time steps, it predict. So this cross line is the predicted one, the green one is the actual one. So it predicts the nearly, it's with a high accuracy. And the third one also has a good accuracy, but the second one does not show much accuracy because you can see this data lines, like first one is no any change, but second one is go down, but the actual price is, actual temperature is much higher. So this model learn once the temperature go in this way, the next temperature should be this lower. So the model couldn't understand this kind of patterns for this model. And so this is the simple neural network implementation. And I also add some convolutional neural network sample also. You can go this later. And let's talk about the most important neural network we use for time series forecasting. The time series forecasting, it is very useful, this recurrent neural network or RNN, because this RNN model can handle the temporal data. So as you remember, in the neural network, before we insert data into our model, we flatten those data. Even though we have 3 time step data with 19 features, we input them as 57 features. But the let's say a feature called humidity, it has temporal relationship between other time step data. But in this approach, the model cannot identify that temporal feature because we are flattened before adding to the model. But in the RNN, we don't have to do this flatten thing. We would input one time step by time step into our model and take the output. That is why RNN is more popular for time series forecasting. And LSTM is one of the RNN layer which is mostly used. And there is a layer called GRU, gated recurrent unit. So they are also very popular. So today I will use this LSTM layer for the forecasting. So this forecasting has, so this LSTM model can have 2 variants. First one is return sequence is true and the return sequence is false. What does it mean by here? The return sequence is false. As I mentioned, we will input our data into this model one step by step. First, we input t0, t equals 0, then t equals 1, t equals 2. So, in this return sequence false scenario, the model will take each and every input and wait until the last time step given. After this t equal 23 is given, the model will output the prediction t equal 24 value. And then we have label t equal 24, then we can compare and take our loss and update the model parameters. So this is return sequence false scenario. And the return sequence true scenario means for each input, the model will output a value. So if we input t equals 0, then model will give t equal 1 value. So for all 24 steps, it will give 24 prediction. Then we can evaluate our model with this 24 label. So this is a sample model which use LSTM layers. Here I use only one layer with 32 units. As you can see, we are not doing any flattening of the data. We just insert the data in a three-dimensional manner. Then this will train and get more temporal relationship between the data. Also, we could use the more layers like this. So this kind of model is not recommended because we use 32 units of LSTM layer, then suddenly we convert into a 1 unit of dense layer. So this kind of model cannot identify much temporal patterns. So you should gradually increment or decrement the number of units in the model. So this approach is much better. Like first you have 32 units, then move to 16 units, then 8, then 1. So this will be a good approach rather than this one. So once you implement the model, you can take the input and output data. The input shape will be 32 batches, 24 time steps, and this time step, as I mentioned, each time step will be given one step at a time and 90 features. So with our model, this is the output. For each time step, it will give an prediction. And our desired output is this last one. So you can see this LSTM is more capable of identifying the temporal pattern, the data rather than the normal neural networks. Finally, you can do a performance testing between your all models. Like here, I use dense and convolutional and LSTM. So as you can see, the LSTM gives us the best results as it is more capable of identifying the temporal pattern in the data. So this is the sample model I want to explain to you. So if any question, you can answer now.
Yeah, I can see three questions in the chat. So I'll go one by one. So the first question is, will shuffling affect the prediction of LSTM of the time series prediction? So yes, very good question. Actually, this is something that I missed to mention. Yes, there are some models that we need to preserve the sequence of the data. So in that case, we have two options. One is instead of using cross-validation, we can use walk-forward validation. So in that case, we preserve the order and we give batch by batch. In addition to that, we can use cross-validation, but we can divide the dataset into multiple batches. And so let's say we have a dataset like 100 records. We can divide it into two batches, 50-50, and then take 40 for training, first batch, 10 for testing, then 40 for training, second batch, 10 for the testing. Likewise, we can shuffle batch by batch. So we can do that, but yes, that is a very good question that I missed. Like, so you need to understand which one model that you are using. So if the model, we need to preserve the sequence of the data. Based on that, we need to use the appropriate model validation that we need to use. So another very good question is, if dataset is seasonal, can we ignore the year? Actually not. Do not ignore the year because there can be some cyclic features as well in the dataset. So if you drop that year, so yes, maybe that's not the requirement, but do not drop any information if because you might miss some important features in the dataset, and but you can add new features, like you can add new feature by ignoring the year and do the prediction, but do not ignore the year because it might lead to data losses and misleading informations, and some you will lose some information as well. So I suggest not to do that. And then did I answer your questions? Like if you have any, if you need any clarifications, maybe you can post it on the chat or maybe reply to this question. And then the third question is, can you tell about ADF test? What is it, when to use, and how to decide? So ADF test is something that we can use to decide whether data set is stationary or not. So so based on that, you pick some model that the data set needs to be stationary. Like most of the statistical model prefer, like Arima prefer statistical, so stationary data set. So based on that, so you might see some trend. So like if you see something like that, if you want to verify whether this data set needs to be stationary, you can do ADF test. There are a lot of libraries that you can use for that. And the only, so when to use is when you are using a model that needs to be stationary. So if it is not stationary and if you want to use this model, you can do some feature engineering. Like you can transform the data, like maybe a log transform, or maybe differences, like you can take the differences between yesterday and today. Likewise, do some feature engineering and make the data series stationary. You can do that. Like you can de-trending, you can remove the trending part from the data set and do feed it to the model like that. So yeah, there's another reply to that. Let's say we remove the outliers, then it can impact some continuous data. Can it affect the model like LSTM? It yes. So if you remove outliers, for an example, if it's obvious, like when you consider outliers, it's very tricky because sometimes it might not so that can be actually a scenario that happen. But so you need to understand the business context. So let's say daily the rates, like you have a certain rates and it's normally going around 200. For some reason, there was like the rate is around 3 or 4 or 10. So that in that case, we can think, okay, this is not something that happened. So we need to remove this data. But actually that happened due to some reason, unknown reason. Uh, maybe like there was a whole, like we don't know the reason. So this is something very tricky. So what you can do is you can uh, try both scenarios. That's what I'm suggesting. Like you can remove the outliers and take a prediction and then predict with the outliers as well, and then see the accuracy of the model. Uh, yeah. Yeah.
Yeah.
Yeah.
To answer that question, can we predict multiple variables in a single LSTM model? We can predict the multiple variables, but you need to have, if you predict multiple variables, you need to have some complex model. Like you cannot use some single layer LSTM model for that prediction. And the multiple variables means the last units of your model. Like last, when you define your model, you will have a few layers. The last layer, you can define much more uh, units if you want to predict multiple variables. So it will normally, it is not recommended to predict multiple variables in a single STM model, but you can.
Yeah. If we create additional features, how we use them to predict our target. So it depends. So this is something that you need to decide. Like, so you have additional features and how to predict the target variable. So yes, you need to like, so this is like, I think it is the fourth step. Like you need to decide because you need, so there are some characteristics that you need to understand. This is not stationary. This is not, maybe the model that you picked needs to be stationary. So then you need to introduce new additional features, like which is stationary, like log transform. Then you can feed it to the model. So then yes, you need to first predict those additional features and then use them. It's totally based on the model because most of the latest models support any kind of data. So then maybe you don't need to uh, like run, like check whether it's stationary or not, but it's still important whether it's stationary and add new features based on your requirement, because new features might give better results uh, than with like not based on the raw data. It will give better results. Yeah. Anything else? Tulasitan, anything else? Oh,
If there are no any other questions, um, we could move to the final stages of the session. Just give me one moment. So, since the session ended on a successful note, I would like to ask all the members who have been throughout this session to please switch on your cameras so we could take a quick photo to keep this as one of the treasured memories. If you are able to turn on your cameras, please turn them on. And we have shared a virtual background in the chat. And if you could apply that as your background, it would be great. And one of our members will take the photo in a while. All right, so we are ready to take our photo. So in three, guys, 1, 2, 3. Photo. All right, I hope our people have taken the photo properly. Um, all right, awesome. So we got our photo. So that was an amazing session, I would say. We covered a lot today, from understanding time series forecasting to applying it in a real world hands-on activity. So thank you once again to our esteemed speakers for the day, Mr. Palinda Athanayakam and Mr. Kavishka Ratnavira. Your expertise and experience in sharing your knowledge with us and also clearing the doubts for all the enthusiastic listeners of the session We are very grateful, and thank you for that very clear explanation with your slide sets and your example that you had prepared for us, even through your busy schedules. So thank you once again, Mr. Palin Datanayaka and Mr. Kavishka Ratnavira. And having said that, there are some minor updates that I would like to give to all the participants of DataCrunch. Competition reminders are that don't forget about the next submission deadline. You can check the Kaggle leaderboard and keep refining your models to get the best scores and mark yourselves up in the leaderboard's top positions. And also, please stay connected via our WhatsApp groups and mailing list for further announcements. And last but not least, keep practicing. Your competition success depends on how much you master everything that you have learned, everything that you are capable of applying, and of course, time series. Having said that, once again, a huge thank you to Mr. Palin Datanayaka and Mr. Kavishka Ratnavira for your valuable insights, and to all of you who are actively participating. See you at the next workshop. Happy data crunching.
Thank you, guys. All the best for your competition. Okay, bye.
Thank you, guys.
Nice. Bye.